Okay guys, this is the Form A from the quiz that you guys took in class on Friday. And so I was going to go over the whole thing. However, I already have a video going over most of this because this quiz is very similar to one we've given in the past. So rather than go over the entire thing, I'm going to make a video going over just the questions that are new this year that aren't on the video that already exists on the YouTube playlist. And I'm going to suggest that for the rest of it, you look at the YouTube playlist so that you're able to go through all of those questions. And then this one will just be basically supplemental because there's only maybe 3 or 4 questions that are different. Plus, the one in the YouTube playlist already also goes over some additional questions that weren't covered very well on the quiz, but that were covered on the test, and some stuff about the free response as well. So that video is already excellent. I'm going to strongly encourage you to watch it. And as I said, on this one, I'm just going to go over some of the new stuff. So these are the quizzes. The one here on the left-hand side is the same one I had on the screen a second ago. This is the quiz you guys took. As you can see, it starts out exactly the same way as the one from a couple years ago. So let's go ahead and see what the difference is. Number 1 says, at what point is the greatest magnitude of velocity? And that is not asked exactly the same way on the old quiz. The old quiz says, where's the lowest magnitude of velocity? But then it asks, where's the greatest speed? And the thing about this is, magnitude of velocity is speed. So number 1 on this year's quiz is effectively the same question as number 2, at which point is the greatest speed. And so that one's already going to be covered. As you can see, question number 2 is identical to question number 3 on the old quiz. And I'm just going to tell you guys right now that this question is a very tricky one, and I would very strongly encourage you to pull it up on that YouTube playlist. It was one that 54% of you got right. Questions 3 and 4 on this year's quiz are about a model rocket. And if we scroll on here, it's in a different order, but you're going to see those same questions right here about the model rocket, and they are questions 6 and 7. So these questions are already covered in the other video. If we keep scrolling, this right here is actually a modified version of question 4. So question 4 in the old video on our old quiz matches question 5. So I'll go ahead and talk about question 5 since it's slightly worded differently, but it's pretty much the same. But question 6 is new. So we do need to go over this question because it was not covered on the quiz video that already exists. So let's take a look at this particular question because it does look a little bit different. It says, use the information and diagrams below for the next 2 questions. And then it says case F in the diagram below represents the path of a stunt car when driven off a cliff with an initial velocity v. In case G, the velocity of the car is twice that of case F. You'll notice it says 2v. Ignore friction and air resistance. So this is the same cliff. And it's the same scenario with the exception of the fact that case F is traveling at v and case G is 2v. So this one's just twice as fast. That's the only difference. But both of them are going to go off a cliff and follow some trajectory and hit the ground below. Number 5 says examine case F compared to the horizontal component of the car's velocity at point A. The horizontal component at of the car's velocity at point B is. And again, this is the same question that was already in there previously. It's just worded slightly differently, but otherwise it's exactly the same. So I'm going to go to the paper copy so that I can write on it. Again, it's just asking you to compare these points and specifically the horizontal velocity at these points. And when you have a projectile, whether it is a projectile that has been launched vertically at an angle, or whether it's a horizontal launch, which this is, your horizontal velocity remains constant the entire time. So again, whether it's a horizontal launch like a car driving off a cliff, a ball rolling off of a table, somebody firing a dart straight ahead, whatever, all of those horizontal launches, your horizontal velocity is constant the whole time. It doesn't matter if I pick a point right here, or A or B, or anywhere in between, your horizontal velocity is going to be equal at every single point. Okay, and that's true also for things that are launched at an angle. Again, if I was to look at like a football being kicked, my horizontal velocity would be constant at every point on this too. So every projectile. All right, now number 6 is new. It is not something that was on the quiz that was given last year, and it's also not something that's in the video that already exists. So this is one of those supplemental new questions that is not already recorded. It is a question that you guys did pretty good on. 80% of you got it right. It says, compared with the car in case F, the car in case G, which leaves the cliff with twice the velocity, will hit the ground blank, and you're filling in the blank. And it is referring to the amount of time that it takes. Actually, this one's referring to speed, but most of them are referring to time. So let's talk about time first. Horizontal motion is independent of vertical motion. So yes, this one's faster, but vertically, it's going to fall at negative 9.8 meters per second squared, just like this one. If it's the same cliff from the same height and they both have an initial vertical velocity of 0, because these are horizontal launches, then the time it takes them to hit the ground is exactly the same. And the final vertical velocity is exactly the same, the vertical velocity. That doesn't mean that the speed is the same at the bottom. In fact, it's not, because this one has a horizontal velocity that is greater. So although the vertical velocities will be the same when they hit, the horizontal velocities will not, giving this one a greater overall speed. So we can cross off the speed one. What we want to pick here is that it will be the same amount of time to reach the ground, because again, both of them have the exact same vertical acceleration, and so both of them are going to reach the ground at the same time and with the same vertical velocity at impact. So your answer to number 6 is C. All right, let's see what else we need to go over that's different between the two versions. All right, so moving on. We have questions about cannon muzzle velocities. Trying to see where those are on here. Here they are. So it looks like those are already in the other video. Numbers 7 and 8 on this year's quiz were 8 and 9 last year. So you can look at the video that exists already for those two. Number 9 was number 10. So again, it's already in the video. Number 10 is number 11. Number 11 is the same as number 12. So a lot of these, like I said, are identical. If we keep going, you'll notice this question is not in this year's version, but this same picture is, if we go past that. Again, those ones that aren't in this year's version of the quiz, still good questions. There's nothing wrong with them. I would still encourage you to look at those and watch those parts of the video, because that's just extra practice for you. All right, now this particular diagram does have different questions. Last year it had 3 questions that went with it. This year it only has 2, and those questions do look different. I will say that this one right here, number 13, in which direction does the velocity vector point, that is number 15 at point B. So that question is actually already in the video, but number 12 is a new question. So let's go ahead and talk about number 12. We can talk about 13 as well since we're looking at it. and then we'll come back to and look for any other differences. So again, this question is new in this year's quiz. Let's see how you guys did on it. Number 12, 66%, so almost 2/3 of you got it right. But it says, how does the acceleration vector at point A compare to the acceleration vector at point C? Again, this is a projectile. And so the velocities are obviously changing. Well, horizontally they're not, but vertically you can obviously see a change in the velocity. And when the two are taken together, you get this curve path. However, the acceleration is negative 9.8 meters per second squared the entire time. This is a vertical acceleration. So my acceleration vertically, AY, is negative 9.8. In the x direction, it's 0. Okay, there is no horizontal acceleration. So the only acceleration to consider is vertical, and it's due to gravity. And so my acceleration vectors, if I were to draw them in, they would all be exactly the same. All of these vectors would be negative 9.8 meters per second, and they would all be the same length. I don't know if I'm drawing them perfectly, but they would all be pointing down. Again, that's the negative sign here, and they would all be the same magnitude, 9.8. And so how do the acceleration vectors compare? Yeah, they're moving in opposite directions. The velocities have different directions at A and C, but the acceleration's identical. So if we look at the choices, we have A points up whereas B points down. That is not going to be true. Both vectors point upward. That is not going to be true. A points forward and up, whereas C points forward and down. This is describing the resultant velocities at those points rather than the acceleration. And then, so that's not our answer. And then the last one is that both vectors point downward, and that's true. All of the vectors point downward at every single point. They're going to point downward, and they're all going to be the same length. All right, so that's number 12. Now, again, number 13 was on last year's quiz, but let's go ahead and talk about it since we're already looking at the diagram anyway. It says, in which direction does the velocity vector point at B? And this is one that students do frequently miss. It tends to be one of the most missed questions because what people think about when they think of max height is they think, oh, the velocity is 0. And that's only true for vertical velocity. The vertical velocity is 0 at point B. However, it's not asking for the vertical velocity vector. It wants the resultant. It's still moving forward. If you throw a baseball downfield, across the field, it's still going to move at the top point. It's just not going to move up and down. It moves forward. And that's what people like to pick. They like to pick this. Peak height implies velocity is 0. This would only be true if it said vertical. It doesn't. And so what direction does the velocity vector point here? It points forward. In fact, at every single point, if we were to add in velocity vectors, okay, then at every single point there, you're going to have an arrow that is identical. They're all the same length and they're all moving forward. Okay, your velocity vectors look like that horizontally. Okay, and of course you do have a change in your vertical, but at this point the vertical would be 0. And so you'd still have a velocity vector, but it would look like that. Okay, let's see what other differences we have. All right, so we have these graphs, which obviously match this, and those two questions are the same. There is a little bit of a change in the verbiage here. It's actually the same question. This is just clarifying because this one just says launched forward, and this is saying launched forward at an angle, which is what the intention was. It just wasn't as clear. So those are exactly the same question as well. This question, however, is not on this quiz. The old quiz does not have this question. So we do need to go ahead and take a look at the very last question on Form A because it is not one that you have seen or will see rather in the video clip. All right, So this is the last one. It says ball 1 is thrown into the air and it follows the trajectory for a projectile shown in the diagram below. Ball 1. At the instant that ball 1 is at the top of its trajectory, ball 2 is dropped from rest from the same height. Which ball reaches the ground first? Let's see. You guys actually did really good on this question. 91% of you got it right, so very few people missed it. And if we take a look at the options here, it says ball 2 reaches the ground first because it has a shorter distance to travel. And that is not going to be your answer. Yes, the distance is shorter because it's going straight down, whereas this one's going forward and down, but the horizontal motion is independent of the vertical. Vertically speaking, your acceleration is the same, negative 9.8 meters per second squared, and so they should have the exact same vertical motion, which means they should reach the ground at the same time. Answer choice B says both balls reach the ground at the same time due to equal accelerations. There is your answer. C says ball 1 reaches the ground first since it is moving at the top of the trajectory while ball 2 is dropped from rest. Ball 1 is in fact moving at the top of the trajectory. However, it does not reach the ground first because horizontal motion is independent of vertical. Vertically, again, this is what we're going to see. These both have a vertical velocity of 0 at this point, and so if they're both starting with a vertical velocity of 0, then after 1 second, both of them will be moving negative 9.8 meters per second downward, and after 2 seconds, they'll be moving negative 19.6 meters per second downward, and so on and so forth. They will have the same velocities after each second, which means they're also traveling the same vertical distances each second. Last one, not enough information to tell. Obviously, that is incorrect. So the answer to number 16 should be B. Again, you can watch the rest of these in the video because the rest of the questions from this quiz are already covered in the video that already exists. So let me show you what that video looks like. You're going to find a link to this in My Open Math, Unit 7 Lectures, Projectile Motion. And this is the playlist. Now when you open it up in My Open Math, it looks like it's just the first video, but it's not. It's an entire playlist. You can like hover over it and get to the playlist, or you can use the link to open it in YouTube and you'll see all the videos. If you scroll to the bottom of this list, here is, it says 705 Solutions Explained. This is your unit summary this year. It wasn't in the past, but it is this year. So I labeled it Unit Summary 25-26. So if you're getting stuck on any of those, watch that video. This is the video of the quiz that I was just comparing this year's quiz to. You'll notice it's an hour long, but that's because I also go over some questions in the unit summary. I say, hey, review number 5. And then in 702.3, I also mention that you should go over these things because those concepts weren't covered very well in the quiz, but they are things that show up on the test. So again, watch the video, or if you don't want to watch the whole thing, scroll down and it lets you skip to specific questions. You can click on the timestamp and it'll take you right there. You can see which ones were most missed. Number 7 on this old quiz was the most missed question, and it is at 7 minutes and 27 seconds. Here's all the timestamps, but again, you can also see those. And then other questions to review before your test. So if you want to skip around, you can. But again, you're also going to want to look at the questions that I just went over because they're not in this. So that would be my recommendation, is to look at these and look, especially the ones that were most missed, and then also look at the ones that we added on. You do have a free response question in addition to the multiple choice stuff, and then also I'm going to be posting a video of myself going over the little half sheet that you did today in class for bonus points, those little FRQ sheets. So there will be a video for that as well if you weren't sure about it, or if you just want to make sure that you got it right. All right, guys, you have a test tomorrow. Make sure you're studying. Good luck.